we did not import anything. We did not say from handlers.pages import index. We could have done it. We could have come up here and said from handlers.pages import index, and then we could have given the index function to heaven, and then heaven will run and it wouldn't have a problem. But if we have many such functions in different places, we don't want to be importing every single time. So what we want to do is we trust heaven to be smart enough to be able to import the function by itself. So we just give it a string, and heaven is going to go ahead and import the function and run the function whenever we visit that page. Okay? So it makes it stupid simple for you to build applications. You just say, if somebody visits this page, call this endpoint. If somebody visits this page, call this endpoint. Okay? So that is how you multiplex an address to a function. You can pass the function heaven and called whenever someone visits the right route and visits the right with the right method. Okay? So okay, so we have here app.get. We need to take a look at. We cannot an address for every single page on our website that we want to page for on the fly. Okay, we want to do it dynamic. If you have a question, raise your hand. Have I lost everyone? Have I lost anyone? Are we following? Okay. Is it understood? Okay, happy to hear. So what we're going to do now, what I want us to now do is, I want us to create, us to create an application. So tell me what exactly we need to do. Tell me what exactly we need to do to build a Heaven application. What is the first thing we need to do? Where do we need to import something from? Not all at once. No, not import environs. We need to import, so what is it that accepts the application from the browser? Zainab, what is it that accepts the application from the browser? Yes, we need to import Heaven, but it's not exactly Heaven that we're importing. We're importing something from Heaven. What are we importing from Heaven? Now, response and request is what we import when we're building the handler. But there's something we're importing from Heaven that actually helps us build a web application. Import app. Ooh, yes. Lovely. So import app. So what is the command to import app from Heaven? What is the full command to import app from Heaven? From Heaven, import app. Lovely. Okay, we're on a roll. From Heaven, import app. Okay, so now we imported app. Okay, we want to create an application. What do we need to do to create the application? I'm looking at you, Zainab, as well. You had a wonderful answer earlier. So, from Heaven, import app. What is the next thing we're going to do? declare function create a server. True, true, true. So how do we create a server? No, no, that's how we declare a function. How do we create? So we imported the app. We need to create the app. What do we do to create an app? I can give you the first part of it. We say app is equals to, what do we do after that? App is equals to, what do we do after that? What do we do after? App is equals to? Anyone? Someone? How do you create an instance? We spent a lot of time talking about banana bread and how you can use the recipe to create many banana breads. So how do we create an instance of an app? What is the syntax? App is equals to app. Lovely, 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 lovely. App is equals to app. Beautiful. App is equals to app. Now we have an application. Okay? Now we have an application. How do we tie the application to a Python function? We're going to say app dot get, okay? So what do we do after we say app dot get? So basically we have an application, okay? This is a web application. We need this web application to listen to the browser and send web pages or text or data back to the browser. So how do we get this application that we just created from heaven import app and app is equals to app? How do we get it to respond to the web browser? Remember, this is, now we're taking a look at initialization and we're taking a look at Python function creation, okay? How do you create Python functions? How do you call Python functions? How do you utilize variables? Okay? Wonderful try from everyone. Wonderful try. What we are going to do is we're going to say app.get and we give it their address, and then we go ahead and we say handlers.pages.index. 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 Okay? So here we have the app, and the app is handling a GET request to the home page. So there are a couple of things that we can use to specify that we want the app to generate pages for us. Okay? We want the app to generate pages for us. So we say app.get, okay? If we put prices here, then the app is only going to respond to the prices page, okay? But if we put that we want this to be dynamic, okay? Or we want it to be like a name or whatever variable we put here, and then we say we want this to be dynamic, then what happens here is that whenever someone visits a page that is /about/prices/whatever, okay? Because we put the colon in front of this, it will be sent to the dynamic function. It will be sent to the dynamic function. Okay? So, what we're going to do now is we're going to take a look at some higher level functions in Python and see how we can use that to inform ourselves on what to do in the context of building a web application. Okay? So let's take a look at, or what we can also do, instead of jumping into that first, we can take a look at routing. Okay? We can explain what routing is, and hopefully that will give an idea on why this would handle all these pages. Okay? So when we have a web page, now there's something about web applications, okay? There's the whole concept of hypermedia as the engine of application state. Okay? And there is a way that we can design our websites or our web pages that they're discoverable and they're consumable by a multitude of clients. So usually when you want to build a website, if you're not familiar with how what goes on, so basically when you visit a web page, your browser will send /. Let's come here to when you visit a web page, so if you go to google.com, what your browser sends to Google is just this, okay? That is the default. That is the default route. That is your index route. That's what your browser is going to send whenever you just go to google.com, workstation, and daily trust, TDHI, it's going to send /, okay? If you go to google.com/ I'm assuming some of us might still be creating our GitHub account. Please go and create a GitHub account. It's super important. It's extremely important. Very, very important. Because the truth is, if you want to work as a developer, many companies are going to ask for your GitHub account. Okay? And then if you create a GitHub account, it indicates that you're serious about your craft and you're serious about this journey that you're embarking on. And it's free. Plus, if you create one, you can go get a cool name, a cool name for yourself. Okay? So please create a GitHub account if you haven't created one. Super important. Okay, so moving on. Now, we have here the main, the app.get, app.get, app.get. So what we want to do is we want to also create a way for us to get we want to create a way for us to like an API so that the necessary accounts can be created. Like you want to create a volunteer or you want to create an enabler, we need a way to save that. Okay. So one of the things then that we are going to do is we're going to take a look at the. So we have layout.ginger page, okay? We explained how the block goes in there. Now let's take a look at the wildcard, okay? Let's change this to dynamic, and then let's change this to dynamic because it's not really a wildcard; it's just a dynamic page. Because the wildcard page would be, we want to catch every single page that comes in. To do that, we're going to say app.get, and we're going to put this star. Now that is a wildcard, because it's going to catch every single page that comes in. That is not dynamic. So this is more important than dynamic, and dynamic is more important than wildcard, okay? So it goes from here to here before it gets here. So if there's a page that exists, wildcard will not caught. Okay? So here we have, if we want to create a wildcard, we're going to go /star to create a wildcard. Okay? We're going to go /star to create a wildcard. So let's first remove the wildcard so we can come back to doing the. So we can go back to taking a look at the dynamic. Okay? So when we take a look at the dynamic, you see that we have the 3 arguments required for this to be a handler for heaven, okay? And then what we're saying here is the page is equals to request dot params dot get page. Why are we able to do that? Let us go into Python for a bit, okay? Let's go into Python for a bit. Let us split our screen and type Python. Okay, so you can see my screen, yes? What we can do is actually make this slightly bigger and open here, say C, type Python. Okay, so hopefully that is bigger. Okay, so here we're going to play around. This is the Python read, evaluate, print loop, like a REPL, okay? And then you see it here, okay? Like this is the Python shell, the Python environment. So this triples angle bracket here. Whatever you type inside here is going to be evaluated by Python immediately, just like that. So let's go in, okay? So here we have, we're going to create a dict. We're going to create a dictionary. We're going to create a dictionary. So let's go ahead and let's say our bucket, okay? And then we're going to come here and we're going to say that the name is bucket 1. The success is equal to true. The records is 2, and the data is ID 1, title not there yet, and then ID 2, title in progress. Okay, so what we have done here is we've created a dictionary. Now, let's take a look at what is going on in this dictionary, okay? We can say import JSON, and we can say JSON.dumps, okay? And we can go ahead and say bucket, okay? And I think we can actually, I'm not sure if it's print is here. Let's take a look at the print version of it so we can quickly explore. I think this might be it. Okay, so what we have here, we have this is a dictionary. You can see it here. It's a full-blown Python dictionary, okay? So what we have here, we have the name, and we say it's bucket 1, okay? We have the success, we say it's true. We have the number of records, we say there are 2 of them. We have the data, and we say it's an array or a list of 2 dictionaries, okay? So how do we get data from this dictionary? Important that you understand what we're saying here. How do we get data from this dictionary? I'm going to say it one more time for the people in the back. How do we get data from this dictionary? Well, if you said we're going to use the get keyword in a dictionary, you're 100% right. Whenever you have a dictionary, here our dictionary is called bucket. Bucket.get will give you something from the dictionary if it exists, okay? If it doesn't exist, it's going to give you null or none. Because Python, there's no null, we have none. So if I say bucket.get yimu, there is no yimu in this, okay? So it gives me none, okay? If I say, another way to get it is to say bucket, and then I put this one, and I say name, and it's going to give me some data back. Now the difference between bucket.get and bucket with the name, the attribute access, is that if this doesn't exist, if I use yimu like this and doesn't exist, it's going to throw an error, okay? Key error yimu does not exist. So get is safer when you're not sure if the key exists, but if the key exists, then get is going to give you the key in the dictionary, okay? So the way that you get data from a dictionary is you say dict.get. So whenever you see me using .get, it's most likely a dictionary behind the scenes, okay? Now, why do we use dictionaries? Because dictionaries they have very quick lookup, okay? So we're going to go into okay, we're not going to go into it, but one of the things that I challenge you to do is to take a look at algorithmic like performance, big O notation, and then educate yourself on it. If you want to get a job as a software engineer with any organization worth their salt, then you're most likely going to perform an interview, and you're going to have a session where they ask you around why did you do what you did. It must necessarily be like conversations around big O, but like why did you choose to implement a specific technology? It's in a whiteboarding session, or why did you choose to solve the question using the strategies you used? Okay, so you want to cut your teeth on taking a look at writing performant code. Okay, the dictionary is 9 times out of 10, like perhaps one of the quickest ways to solve a problem with good performance. Okay, so if you can use a dictionary to model your data, please do. Okay, but again, the more time you spend programming, the better you're going to get at this. So let's take a look again. So we have the bucket here, and then if we say bucket.get data, what we're going to get back is a list. And remember, it's a list because if you take a look here, you see it is actually a list. So if we say bucket.get data and we say 0, we're going to get the first item in the list. Okay. So if we say 0 and then we say .get ID, we're going to get 1. Okay, so we got the data, which is a list. We got a 0 index item, okay, which is a dictionary, and then we used get to get the ID, which gave us 1. Okay, so if you want to get data from a dictionary, you use .get. Okay, if you want to get, you can also use the bucket, and then the index is going to be the key, the same way you do with an array. Okay, you would say bucket name or bucket data, okay, 0 ID. Okay, so we use the different style here. We said bucket, okay, give us data, which will give us an array, and then an array uses the number or the position. We use 0, and then we got another dict, and then we use the key again, and then we got 1. Okay, so when you have a dict, you can use dict.get, you can use the index, okay, the key to get data out of the dict, and then if it's a list, you're going to use the position, which is going to be a 0-based index. Okay. So here we have taken a look at the dict. So if we come back to the application, when we say here request.params.get, params is a dict, okay? That's what params is. Params is a dict. So we're saying request params.get page, okay? So we're going to get this page from the dict, and then remember this page here is whatever the browser sends. If it sends about, directories, financing, hearts, hands, hearts, then we're going to allow it. If it's not there, then we're going to say not found. So what exactly is happening here? Let's come back to Python, and then let's put this here, okay? But before we continue, how do you get value from a dict? How do you get data from a dict? How do you get data from a dict? How do you get data from a dict? Google Chrome is rubbish. Dict, not dict. How do you get data from a dict? No one? How do you get data? Let's type it here. How do you get data from a dict? From a dictionary. How do you get data from a dictionary? Anyone? What about from a list? How do you get data from a list? Selecting a Monday, Destiny, Atta, Victor. How do you get data from a list? So let me type the question in the chat. Imagine we have how do I get true? How do we get true from We have 3 minutes to answer. Very simple, straightforward question. If you can't remember, please ask. Because being able to access or iterate over lists is super important. How do we get data from the list? How do we get data from a list? One minute to go. How do we get the true from the list that has been shared in the chat? No one can answer. Is everyone afraid to look bad? We're learning. How do you get data from a dict? Okay, so how do you get data from a dict? Well, the quickest and the easiest way is just to use dict.get. Okay? You use dict.get. And from a list, you're going to use not slicing, okay? You're going to use the index of the item. You're going to use the index of the item. So, okay, so what we're going to do now, we're going to take a step back away from exposing ourselves to and trying to use a live project to explain core concepts. We are going to just go ahead and we're going to go ahead and yes, from addict to use a key. That's true. But what is the syntax for it? What is the syntax for it? What is the syntax for? Okay, so we're going to go ahead. So what we're going to do now is we're going to take a look at getting data from collections. Okay. So given that you have a list which can be true, false, 5, maybe none, okay, 3.2, and addict, and an empty array, and another day, okay? So we have this list right here, and we want to get items from the list, okay? Now, it is possible to get a subset of items from the list. Now, when we were taking a look at JavaScript, we said you could use the spread operator in JavaScript. You could use the spread operator, and then the same thing for the dictionary. You could use the spread operator. Now, for the data we have here, we can say like the key is equals to 45. We can say value is equals to true. We can say age is equals to, let's say age is equals to 45, and let's say here that is equals to none, okay? And then we say error is an empty string. Okay, so we have two things here. If we want to get the if we want to get the data, okay, from, if we want to get maybe, okay, let's count. Remember what we said. If you have a list or if you have a dictionary and you want to get data from the list or you want to get data from the dictionary, there are a couple of ways to go about it. For the list, there's only one sheriff in town. You basically get the index for the item. It's when you want to search a list that then it gets expensive, because imagine you have a list of 1 million items and you want to search the list for the 1 million items. Then it's going to get expensive very, very, very quickly, okay? So if you have a list and you know the position of the item you want to get, is pretty fast, okay? So let's say we want to get 5. We're going to start from the beginning. 1, 2, 3, minus 1. So we'll say given, okay? 2 will give us, given at position 2 will give us 5. Now, why do we say this? It's because a list, an array, irrespective of the programming language, okay, they're always 0 indexed. They always start at 0. So in other words, this here is 0. This here is 1. This is 2. This is 3. This is 4. This is 5. This is 6. This is 7. And this is 8. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. But the position for true is 0, the position for 4 is 1, for 5 is 2, for maybe is 3, for none is 4, for 3.2 is 5, for the dict is 6, for the array is 7, and for A is 8. Is this clear? The 0 indexed nature of a list. Is someone still stumped about this? If I say, how do I get a data from a list, are we going to be able to just go ahead and say you're going to use the index? Now, whoever is Joseph Coxton, I think it's one of these spammers, so I'm just going to go ahead and deny entry. Okay, so given the zero index nature of a list, an array, if you're using JavaScript speak, then if you want to access an item at position 3, you're going to say the item at 3 minus 1, which is going to be 2, okay, because it's 0 indexed. Always remember, lists are 0 indexed. JavaScript, Python, doesn't matter. Lists are 0 indexed. Golang, C++, C, doesn't matter. Lists are 0 indexed. Okay, so if a list is 0 indexed and we want to get 5, then we're going to say the given at 2 is going to give us 5, okay? Now, what about a dictionary? Dictionary, we're going to say the data, okay, and we're going to give the key. If we say that, it's going to give us none, okay? If we say value, it's going to give us true. If we say age, it's going to give us 45. If we say error, it's going to give us the empty string. Is it clear? Okay, we can use this, or we can use data.get and pass in the...
Are you taking a 10-minute break?
I want to take 5 minutes.
5.
How many minutes? Let me finish. So this is the way that you can get data from dict. And are there any questions? Not all at once. So when we come back, we're going to take a look at traversing dictionaries and traversing keys. We're going to take a look at how do you traverse dictionaries and how do you traverse keys. What is enumerate and what is list comprehension, and what are the ways that you can take a dictionary, iterate over it, extract data or extrapolate data, or generate a dictionary from data. We're going to take a look at maybe some functions like the zip, what they do, or maybe we'll use that as an assignment, okay? And much of the collection classes, set, tuple, what are the differences that exist between them, what is ordered, what is unordered, and things like this. So we're going to go on a 5-minute break, most likely 5 minutes. And if you have questions, feel free to ask. Even if the break has started and you have a question, please ask. When I come back, I will take a look at the chat and I will answer. The floor is yours. Okay, so after we're also done with the collections, we're most likely going to jump into SQL as well, because we need SQL to be able to do some of the things that we need to do, or SQL. Thank you again all so much. It's super fun talking to all of you, and I'm super happy that we are picking up some of the things that have been laid down. I hope that we ask more questions, and I'll see you guys in a few minutes. Yes. How many minutes do I have?
of all the times that we have accrued. No, now. No, now. we are going to continue where we stopped. Now, earlier we mentioned that we were going to. Earlier we mentioned we were going to take a look at how to generate data, miscomprehensions, how they work, and a couple of other dictionary manipulation operations. So taking a look at the data that we have on the screen, before we jump in, I'm going to go ahead and delete this, and I'm going to ask the same question that we asked a couple of minutes ago. How do we get data from the given the maybe item from the given list? How to get the maybe item from the given list? Not all at once. Not all at once. Sute, if you're there. Toye, Osha, Ogbona, Nathaniel, John Ogo, if you're there. How to get maybe item from the given list? How did it maybe item from the given list? Anyone? We need to answer this question so we can move to the, and if it's not something that we grok, then we revisit it again so that we don't. I can go ahead and give a sample. So we're going to say given. So what are we going to put inside? What is question mark going to be? What's the question mark going to be? The community says it's going to be 3, and he's 100% right on the money. Beautiful, 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 beautiful. Yes, it's going to be 3. So to get an item from a list, we're going to use a 0 indexing strategy to get the item from the list. Yes. And to go 2 for gold, what are we going to do, or what are we going to put into there to get 45? What are we going to put in data? Data age. Yes, 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 yes. It's going to be the age. Wonderful. Thank you so much. And another way to get it is to say data that get age. Okay? Data that get age. Okay, so taking a look, then let's open this, and then let's write some code. Okay? So let's copy this from here, and let's paste it here, and then let's talk about slicing. Okay? So slicing is taking a version of a list, okay, from a start point to a desired endpoint. Okay, so if we say, and I'm going to teach you a couple of strategies as well. If we say we want to take the list and we do this and we put a -1, what is going to happen? Who can guess? We put colon, colon, then we put a -1. What is going to happen to the given list? Who can guess? No. Given colon -1 not equals to. So you notice that it's going to be reversed, okay? When you do colon, colon, -1, the list will be reversed. And if someone can explain why, then they're going to be my co-pilot, my go-to praise partner for the night. Whenever I want to offer praise, I'll send it away. So anyone wants that that title? Go ahead and explain what's going on here. But let's take a look at exactly what we mean when we slice. So if we say given and we say from 1 and we put all the way to the end, what you see here is that we excluded true and started with 4. And if we say given and we say 0 and we do like this, everything goes all the way to the end. What do you think is going on given the 0 indexed nature of lists? And then what happens if we actually put a -1? Notice that it goes all the way to the end. So if we put a -2, it's going to start from the end here and go like this. -3 is going to come like this. So when you see -1, it starts from the bottom, like from the end and goes, okay? But what happens when it starts from -1 starts from here, okay? -2 is going to go like this, and 3, and it's going to go like that, okay? So what happens when we say given, okay, and we say from 0 and we go to 1? We get just the first item, okay? So what does that tell you about the one that is here? Is it
okay, you take a slice of the entire array. But then when you go like this, it reverses the list, okay? And this is a trick question that some Python misters. Question. Slice syntax, okay? So, no, come here to python.org, not here. Slice syntax for lists, okay? No, python.org. Why is python.org's so python.org is not python.org slicing. Okay, anyways, let's not waste our time. When you do this, you're basically saying you want to, it's the offset, how much you want to skip. It's like a index skipping, basically. Okay, so if you have tree, you have the start, you have the end, and then you have the index skipping. That is why when you have empty, 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 and you use -1, it starts a reverse skipping, and then it reverses the list. So if you give it here given, and then you say 0, and then for instance you say 4, and then you say 1, you see? So it gives you an index skipping of 1, and then if you say 2, it gives you index skipping of 2. You see that? So if you take a look at this, you see true and 5, okay? So it's the index skip, and then when you put -1, it starts from the reverse, and it gives you a reversal of the list, okay? So, but I wanted to show you on python.org so you can have a reference to use list slice index skip. Okay. So we have here slice I'll find the link and I'll give you later so you can take a look at from python.org and not from many of these other places. Okay, but it's basically the skip index, okay, for the slice. Okay, so moving on to this, okay? So moving on to iteration 4, okay, and list comprehension. So if you have something like this, okay, we can actually say for item in, let's say we have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, okay? Okay, so this is list comprehension. Basically, you can iterate, and it's not just for lists, you can also do it for dictionaries. So you can come here, you can say A, and you can say V for V in, and you can use it for generating dictionaries as well. So let's take a look at a perfect use case, and let's not use the REPL, because I want to use the VS Code editor. So let's come here, Command J. Okay, so now imagine that you can say your data, and you can say K, V, okay, for K in A, B, C, D, okay, and then you can say something like v.get K, for instance, and let's imagine that V here is a dictionary, okay? So you can use the same concept. You can generate values. Now, there are numerous times when I have been creating applications, and maybe if we're creating an application and then there's data that comes from a database, you might see me use like the dictionary comprehension to get data, traverse data, extract data, and play around with it. So when you have data or in a format that you want to, okay, let me take a look and see if I can get a sample, live sample, or a perfect example to use. So let's see. I have kv.get K because this is nuanced. But this, what you're going to get basically here, you're going to get K is going to be A, B, C, and then V is going to be none because this is empty. I'm trying to look for something that you actually also get values back for V. So, okay. So something that we can actually do is we can do this. Okay, yes, let's do this. Let's say Command J. Okay, let's come here and let's say KV for KV in enumerate A, B, C. Okay. So this is a perfect example, okay? So here we have KV for KV in enumerate, and then we're enumerating a list, okay? So what we're doing here is, let me see if I can make this bigger, okay? What we're doing here is we have Ctrl-C, let's exit from here. Okay, so what we're doing here is we have a list of items, and then when you enumerate, basically what you get is the enumerate takes for every item, it gives you the index position of that item, and it gives you as a tuple of key value pairs. So let me show you. We say enumerate, let's say A, B, C, okay? You get an enumeration object, and then if we say here, K, you can actually even say VK, okay, for KV in enumerate, and then you say A, B, C, and then you get the items as the key and the index as the value. You can even go crazy and do things like VK plus 1. So you say VK plus 1 for V in enumerate. So like there are lots of things that you can do, and it becomes more powerful when you have like live data and you see the structure of the data and you're like, oh, okay, so this is what I want to remove from the data. I want to work in this way. I want to extract the indices. I want to perform an operation on the indices. You can even add conditional logic such that you say if V is something and then it's still going to work. So it's a very, very powerful tool, dictionary and list comprehension. Now, ideally, you don't want to do it on large value items. You don't do it on items that are too long, because then you have a performance hit of sorts. Again, always recommend that if you're going to work with a data structure, you work with a dictionary more so than you work with a list, because I can give you like a condensed version of why. So here you have a list, for instance, and we say that for I in, wait, let's do this, okay? Long list is equals to I for I in So this is you see this is a very, very long list. It's not so long, it's just 1,000 characters. But now, imagine that we wanted to get search for an item and the item was somewhere around here, okay? And it was not an ordered list, it was an unordered list. Or you want to search this list for an item for where a specific value is equals to something. The only way you'd be able to do that would be to say for item in LL, and then you say if item is equals to this, and then so you basically iterate over the list, and then you check, and you get your value, which is going to be a very expensive operation. Now, there are a couple of algorithms that you can use to do this, but it's outside the scope of this tutorial, okay? But you always usually don't want to work with lists. If you can, look for a way to extract your data structure into a dictionary. If you absolutely have to work with a list, it's usually best is you can somehow convert that data structure at one go so that every subsequent operation is optimized as a result for it. Okay, so let's move on from that and let's take a look at what we said we were going to do after we covered list comprehensions, slicing, and dictionary. So again, to recap, you can generate and you can write code, and much of the things that you do like this, there is something that the creator of Python said, I think that's Guido van Rossum, about not liking list comprehensions, if I remember correctly. And there's an interview where he was saying, yeah, he doesn't like it. This is the person that made Python. He doesn't like list comprehensions. He believes that there should be a cleaner way to go about it. So what I was trying to say is, you don't have to use list comprehensions or dictionary comprehensions. You can actually go the long route and say for this and this, and then you extract the data that you want to extract and then build your dictionary. You can do that. Personally, I don't mind dictionary comprehensions or list comprehensions. They're a quick way to get the job done. So if you can master it, it's actually a very powerful tool. Again, it's not difficult. You basically say which KV, if you want to, for some item, for some condition, you can enumerate if it's a list, or you can extrapolate and then use KV from what you're extrapolating, okay? And if it's for a list, you do A for A in whatever, okay? So there you go. Let us come here, and we've taken a look at lists, we've taken a look at dictionaries. Yes, we talked about tuples, and we talked about sets, okay? So now, if I have, so the difference between a list and a set is that I can have something here, so I can have AL, and I can say A4, okay? And then if I said set AL, okay, what I get back is just 4 and A. So the reason why I put A4 is so you can see that in a list you can have duplicate data. In a set you can have duplicate data. So sometimes if you are looking for something and you really don't care about like you want to check if something exists in a collection, sometimes it might be better to just turn it to a set, because then you can make sure you get just the unique items, and then you can search a set instead of searching for a list. Okay, that's one way to go about it. So a set is unique, while a list is not. Okay. So now the last item that we're going to take a look at is a tuple. Now for this, I want to excite you a little bit, and I want you to take a quick search. You can check and say, what's the difference between a tuple and a list? It's quite simple, actually. So if you find it, you can put it in the chat. The difference between a tuple and a list. What is the difference between a tuple and a list? Now, another thing that you can do, okay, please make sure you get very, very good at finding information online. This is something that I'm hoping that I can reinforce over the course of this session. Get very, very good at finding information online. Some other places you'll find information, Stack Overflow. So, very, very wonderful community. Before you ask a question on Stack Overflow, make sure you check to see that the question has not been asked before. Chances are it has, but it's a very powerful community for finding answers to questions you might have. Another powerful way is to go to GitHub and go to the actual library that you want to use. So let's say, for instance, we're using Valkey, okay, which is the new iteration for Redis, and I'm having issues with Valkey, so I come to Valkey and I'm going to click on issues. Okay, this is another wonderful place for you to get solutions for specifically the problem that you're facing. Chances are, if you come here and you search, you are yes. So chances are you are going to find what you're looking for here, because if you're facing a problem and you know that it is not a problem that has to come from your code, then chances are that it's the library, and then if you come, you're going to get issues. So issues are things that people have found and they've created, and then the maintainers of the library can solve. So this is another good way for you to find solutions to some of the problems you might have. Go directly to the GitHub page, the GitLab page, whatever, Bitbucket, whatever version control system they're using. Click on the issues and see if something like that exists and if there's a patch or a fix for it. It has helped me more times than I can count. Another thing is, this is a good way to actually get, become a trusted, like a committer, not a trusted, at least you have commits to open source. You take a look at the low-hanging fruit, maybe something that has to do with like a typo in documentation, and you fix it, and like that, you're getting your toe in the water. Okay, so these are strategies that you can use to. These are strategies that you can use to get your feet wet with open source technologies. Okay, so moving on, we are going to we are going to take a look at the, let's come back here and then let's do this, okay? So if I do something like this and I say 3 and I say true and I do this and I say type of a T, I'm going to get a tuple, okay? I'm going to get a tuple. So that's a very, very quick way for you to get a tuple, okay? Now, if I did like this, I'm going to get a list, okay? I'm going to get a list, okay? If I use parentheses, I'm going to get a tuple, okay? So very, very quick. We are at the 25-hour mark. I want to make sure that we are able to get into SQL and take a look at a couple of data lessons, okay? So now, again, one of the things that you're going to find out as you spend more time programming is that you spend a lot of time defining and changing data from one format to another, and a lot of the times you're going to be working on applications that have to do with persisting or saving data, okay? Persisting or saving data. Now, there are numerous ways that you can save data, okay? You can save data, you have NoSQL data stores, you have SQL data stores, you have graph databases. There are a couple of them. From RethinkDB to Arango to Mongo to Postgres. So what I am going to do now is, who can give me example of document databases, okay? SQL databases, like 2 of it, and graph databases. Take a quick look, take a quick search on Google, and then give me an example of a document database. There's a very, very popular one. I already mentioned one of the names. SQL databases, there are a couple of them. There's, yeah, I'm not going to give you the answer. And then graph databases, okay? I also mentioned one of them already, okay? And then not just the name, they're useful in specific instances and columnar databases as well. So I'm hoping that we can touch on different database types. Most likely we might, if we cannot, maybe we'll touch on two of the database types. And then if we also have time, we'll take a look at some fine-tuning. We'll take a look at what it means when we talk about ACID, when we're in the SQL space, okay? We'll take a look at isolation levels. We'll take a look at, oh, this is something that is important to know, even as people that are just learning programming, the CAP theorem. And we're also going to take a look at so we're going to take a look at ACID, we're going to take a look at the CAP theorem. We're also going to take a look at some of the distributed technologies. Okay, so yes, distributed technologies. Okay? Technologies for distributed computing. Okay, so these are some of the things that we're going to touch base on. Okie dokie. So remember, tuple and list. Okay, so let's exit here and let's clear screen. Let's come out. Let's leave here alone. And okay, so we'll leave the example.py file and waiting for who is going to submit the document databases. Who's working on document databases? As you submit the document database, now I explain what it is, why it became so popular. I'll tell you a couple of popular ones. And then if you submit SQL databases, I'll also talk about it. And then when you submit graph databases, I'll talk about it. And then column databases, I'll also talk about it. Okay? So, and they also have uses in different areas as well. Okay? Okay, so to make sure that we keep the learning moving, I just will go ahead and talk about databases. So please post the whatever you found in the chat. Okay, and then if you have questions, you can ask, and I'll try my best to answer. So for I'll talk document databases, SQL databases. If you have time, graph databases. If you don't, I'll just touch this too. So for document databases, now the reason why document databases became very, very popular is because if you take a look at JavaScript, in JavaScript land we have the object. We took a look, remember earlier we took a look at JSON.stringify, okay, and then we took a look at JSON.pass as well. And in the Python space, we took a look at JSON. Who can remember the code, the Python API for parsing JSON data to a string? We said from JSON import, we imported something. We can remember. We said dumps, okay? From JSON import dumps. So here if you say dumps and you put the dict, it's gonna dump. Okay, so now in JavaScript and in Python, you have dicts, okay? So you have your data and it's usually in the form of a dictionary. And the thing that a lot of people started complaining about was the object relational mismatch, okay? The object relational mismatch. And this is something that you can Google real quickly and it will give you, and you can read about it later, okay? So now the basic reasoning, like very high SQL databases. Thank you, Mavius. This is wonderful. Okay. Document databases, definition data store in documents, yes. And they're flexible, yes. Scalable, high performance, easy data retrieval. Now, okay, so we're back. That was quick. Kudos to the wonderful tech team for making sure that our mic is working. Hats off to all of you. Okay, so now, when you have a language like Python or JavaScript or whatnot, you're usually working with objects, okay? Or you're working with data that is not in relational format, because the relational format is more tabular, okay? If you've seen, and think of it like an Excel sheet on steroids. Of course, I'm oversimplifying relational databases, but it's a table, okay? And then you have the normalization that happens to data, and we're gonna take a look at normal forms much later, okay? But the data that you store in a relational database is tabular, okay? But the data that you store in a document database is, like, if you take a look at MongoDB, it's like a practical match. You can have nested data, so you don't really have to change the structure of your data because you're saving it to a database. And let me explain, and let me show you an instance. So imagine that we're talking about volunteers, okay? Now, if we wanted to create a table to manage volunteers, we most likely would say, okay, so we have the volunteer name, okay? Let's do this here, okay? You have the volunteer name, you have the profession, and then maybe you have the location, and you have a couple of other, and just here already you can start seeing things that you might need to remove and put in your own table or in your own space. You might need to start thinking about how do you remove location and put it in its own space so you can track all the locations where you have professionals. You might start thinking about, okay, what about professions? Do you want to track that as well? And then the thing about relational data is as you separate parts of your data and it lives in separate tables, you're going to have to join them. So when you're making a query, you're going to say select all from professionals join locations where this is equals to that, and then you're going to have to aggregate data, okay? So many times, some organizations go into the habit of denormalizing their data or having their data not as normalized so that they can keep paths that move together, basically. So you can have data that normally would exist in just one object, okay? You can have the name and you can have like the locations. For instance, if the person is in multiple locations, you can have it like an array of multiple objects. But then the minute you go into relational land, you're going to have to break this data into a relational format, okay? For data integrity sakes and whatnot. So document databases became very, very popular because you don't have to change the structure of your data. You can take your data just the way it is, save it into a document database, you get the indexing capabilities, you get a couple of other niceties, and then you don't have to be worrying about, oh, how do I break down my data into different parts, okay? So that's why they became very, very popular. A couple of very, very popular document databases. The most popular one you probably come across will be MongoDB, okay? There was one called RethinkDB, and you can take a look at it. I'm not sure if it's still working. I think at some time it stopped. And then there's Google Cloud Firestore. Okay? So these are some of them that you can take a look at. Okay? Now, on the relational side, we're going to talk about atomicity, consistency, isolation, and durability. Yes, someone already posted it in the chat. Wonderful, wonderful, wonderful. So the whole idea behind ACID is that if I want to think about, and this is why many banks use relational databases, because there are very strong guarantees that many of the, like they allow you fine tune, like when we talk about the isolation levels, you have read uncommitted, read committed, and there are specific things that they prevent from happening as well, okay? So it's not that it's not important. So when we go into full detail of why the isolation levels are important, what isolation levels exist in some databases, like I think in Postgres, you don't have dirty reads by default, if I remember correctly, but in some other databases you do. So there are some things that can happen, and so the isolation level prevents you from having inconsistent data, phantom reads, and a couple of other things. Okay, so atomicity means everything succeeds or everything fails. You don't have data in an inconsistent state. So all transactions are executed as like if you execute a transaction, everything in the transaction is either all going to succeed or all going to fail. Okay, so consistency is more so that there is, like, when data, your database is not in an inconsistent state after a transaction has happened, okay? Like the database is in a consistent state, okay? Isolation is what we talked about, dead reads and a couple of others, and durability is like there's persistence, okay? Your transactions are going to be persisted. Once you leave, like once you perform your transactions, you know that they are persisted, okay? So that's the whole idea behind ACID, and it's like a whole relational jazz. And then we have graph databases that mostly model relationships that exist between nodes and entities, and that is like imagine you have your friends on Facebook. How do you store the data? How do you store the relationship that exists between you and, like, you are connected to your friend is connected to maybe one of your friends, but the two of you are not connected to each other. Graph databases excel in that area. Okay, so there are numerous ways you can store data, but as an engineer, your job is going to be, again, identifying data and figuring out the best way to wrangle data, move it from one form to another. Chances are, in the wild, I have seen many times multiple types of data stores being used, okay? And so there is no right or wrong data store to use. You can use relational data stores if the problem that you're working on requires some of the strengths that relational data stores bring, then, or by all means, go for it. But if the problem that you're working on doesn't require some of the strengths of a relational data store, and maybe you want a little more flexibility, scalability, then by all means you can go for a document data store like MongoDB. Like, I have seen really large systems. I have been part of really large systems that have been built on both MongoDB and Postgres or MySQL or SQL Server in the Microsoft land. Okay, so the data that you're going to be working on in applications will be stored in mostly around like a document oriented, but then the minute we get to relational land, then you're going to be thinking about, okay, tables and maybe breaking down your data into different parts. Now, not necessarily that you have to understand SQL. Many people use ORMs. Okay, I'm a fan of teaching SQL, and then so you understand what's going on behind the scene. And if you want to use an ORM later, that's 100% up to you. So we are going to be taking a look at how SQL works. We'll be taking a look at what exactly, how do you create tables, how do you read data from tables, and how do you basically structure your data, how do you like transactions, transaction pooling and things like this, so that your application remains performant. Okay, so now, having said all of that, let us leave the JSON dumps conversation and the object relational impedance mismatch. You can read up on it later if you want, and then let's start taking a look at databases. So for this, let me see if I can go ahead and we didn't even touch on SQLite. SQLite is perhaps one of the simplest databases you can use. It's super available. It's so small, it runs almost everywhere. That's definitely something you want to take a look at. Okay, this is it here. So I'll advise you to read it. I definitely advise you to read it, but we're going to be working with Postgres, so I'm not going to touch on it. But by all means, read SQLite. Simple, available everywhere. Comes with Python as well, so go ahead. And okay, so let's come here and connect to okay, so here we have, I'm going to try and make this bigger. So I created a database called TVHI, and there are absolutely 0 tables in this database, okay? Now, we're going to be talking about SQL, and I will be giving a short introduction to SQL or SQL, depending on what or how you want to call it. And the idea behind SQL is that data is stored in tables, okay? Data is stored in tables. Now, we're going to try and rush through the SQL course so that we can go back full circle and touch on the HTML, JavaScript, and Python and start working on the product as we dive deeper. Because we're not going to be working a lot in SQL space, but it is good for you to understand what is actually going on behind the scenes. Now, the same way you have data types in Python is the same way you have data types in SQL, okay? I would advise you to take a look at the different data types that exist, because Oracle has some data types that might not exactly conform to data types that you find in SQL Server. And I'm going to just come here. So in SQL, dash dash is going to be a comment, okay? So Oracle is, of course, a database from Oracle Corporation, okay? and it's very popular, very powerful. And then SQL Server, in my experience, is one of the best databases that I had used for a very long time. It's by Microsoft, which is saying something. And then Postgres is perhaps the most powerful open source database that exists. That's what we're using right now. And then you have MySQL, which was bought by Oracle. And then you have MariaDB, which was forked, like a split away from MySQL. And then there's Cassandra and all the other ones, but we're not going to talk about them, okay? So, but overall, you generally have the variable character, okay, or the text, which is what we're going to be using. And the reason why we're going to be using text is, well, it's beyond the scope, but we're going to be using text, okay? It's going to save us in performance down the line. So we're going to be using text whenever we're talking about strings in Python. And let's go ahead. And seeing as we're using Postgres, we'll be talking about Postgres data types, okay? But, yes, Zainab? You can type a question in the chat. I'm listening, and I'll answer. So since we're using Postgres, we're going to be talking about Postgres data types, okay? Now, what we said earlier was that the data for relational databases is stored in tables. So if we wanted to create what is a database and why do we use it? Okay, so when you have, let's take this and put it here so we can move like this and you see it. We are building an application, okay? Let's see, Command J, UV icon, and then let's say 310, okay. So we are building an application, this application, okay, for the Big Hands Initiative. And when you want to have someone, let's say donate your skill or donate your service, or you want to work with data, you need a place to save all that information, okay? So Python is good for wrangling data, taking data, transforming it, mutating things, and then building web applications, working with data pipelines. But ultimately, you're not going to leave your data in your Python application. Think about it this way, okay? You build an application like Facebook and you have, I don't know, even if it's not an application like Facebook, you have 10,000 users, 100,000 users, okay? Many applications don't get to that level, but you have a few thousand users. You need a place to store their usernames, their orders, their interactions, and all the things that your application, like all the data you collect from your users, okay? You need a place to store all that data. A database, okay, is just like saying, what is your home base, okay? A database is like a military headquarters for data. It is where you take your data and you keep it, okay? Database systems are software applications that have been built, some of them open source, some of them by companies and as such are sold, but they have been built and fine-tuned and optimized to store data, okay, to query data, okay, at high speeds. So when you want to store like lots and lots and lots of data, okay, you can push that data to a database system, and then if you want to retrieve the data, you're going to retrieve the data at super fast speeds, okay? That is what database systems are. You need a database system if you're going to be storing data as you build your application. Now, if you're building a simple calculator application, for instance, you don't need a database because you're just going to be performing calculations and maybe you don't even want to save anything, okay? But if you're building a web application that has to deal with users and they're generating data, then you need to store that application data somewhere. That is why you use databases. You use databases because you want to store your data somewhere, okay? And databases are applications that have been built by companies or individuals in the open source community and have been fine-tuned for fast data storage and data retrieval. That's what database systems are. Okay, so a couple of database systems that we talked about. There's Oracle, SQL Server, Postgres. We're using Postgres. It's open source. It's free. We don't have to pay anyone money. Okay. We can run it on our local computer. We can have our own instance on a public cloud without needing to pay licensing costs. So we're going to use Postgres, and it's also very powerful and very capable. Okay. So if you want to see a side-by-side performance or comparison, you can always, of course, come here, say Postgres versus Oracle versus SQL Server, and you're going to get a biased opinion from people that might have used all three. And then you can make the choice for yourself. If you have money, you can, of course, choose. You can, of course, choose to go with a SQL Server. Like I said, it's a very, very nice system. You can see here it's number 3 overall. Very, very nice system. I actually liked when I used it. And like we said, Oracle is number 1. Like it's by far the market leader when it comes to databases. But it's expensive, and we don't have money to use Oracle, so we're using Postgres. Okay, so moving on. Now we're going to create sample tables just for the sake of demonstrating what databases are and what's actually involved when we talk about creating databases. So we're going to create a sample table, and the first table we're going to create, we're going to call this table volunteers. And if you take a look, you see that SQL is actually almost like English. So we're saying create table volunteers, okay? If you want to create a table, you type create table, and then you give the name of the table. And then after you do that, you're going to open up parentheses, close parentheses, and then end with a curly brace. And then the details of the table will appear inside here, okay? So take a look at this for a few seconds, okay? And then I'm going to delete it, and then I'm going to ask you, what is the syntax to create a table? If I wanted to create a table, okay, called enablers, what am I going to do? Not all at once. What is the syntax? Can't you remember? I want to create a table. How will I go about creating a table? Create table XXX. Ooh, lovely. Thank you, Ahmed. Nice to see you again. So yes, create table XXX. That is how you create a table, okay? You say create table volunteers, okay? Now, we have create table volunteers. We can actually also do this in VS Code, because if you have the appropriate extension, you can do this in VS Code, okay? So we can come here and we can say tables.sql, and then we can come here, we can say create table volunteers. So you can actually also do it in VS Code, 100% up to you, okay? So create table volunteers, and then for volunteers, what information do you think we're going to need to collect from volunteers? Again, this is just for learning purposes, okay? So we're going to say maybe their first name, and then it's going to be a text. And then if we want the first name to be absolutely collected, then we're going to say not null, okay? That's how you say that the first name must be provided. Now, it is also possible that we don't want to even just say first name, we want to collect your name, okay? We want to get your name. If your name is, like, imagine that there's someone that has a single name, Zendaya, for instance, like, just the name, okay? So we say name, and then what else might we want to collect about volunteers? Maybe we want to collect the email, and then we want the email for volunteers to be unique. So if we want the email for volunteers to be unique, we're going to say text, okay? And we can say unique, which would make it unique, so we wouldn't have two volunteers with the same email, okay? Now, what are we doing here? We're saying the name of the data we want to save. This is going to be the name of the column, okay? We're saying the name of the data we want to save. That's going to be the name of the column. We're saying the data type, and then we're talking about the constraints or the rules for the column that we're creating, okay? Now, there is the concept of something called a primary key. Now, in database, relational database parlance, the primary key is the way you uniquely identify a record, okay? It's the way you uniquely identify a record. Now, if we are saying that we want volunteers and we truly want the best, and we want the best for them, we want the best for the people that they're going to be interacting with, then maybe we need some sort of government ID. Maybe we can say we need some sort of international passport, or we need a way to uniquely identify volunteers. So we're going to say that they give us their government ID, and it's going to be a text, and it's going to be the primary key, okay? There are also ways where you can tell the database to generate a primary key for you, okay? But because we are using this as a learning, like a way to create a table, add data to the table, query data from the table, maybe even add a couple of joins here and there. We're also going to alter the table, okay, modify the table, add some columns, maybe drop some columns, just so that we see how simple SQL is. We're going to leave it quite simple, okay? So we have the name, we have the government ID, and we have the email. Okay, so the name cannot be null, the email is unique, and yeah, let's go ahead and create this table. So let's run, and then just like that, we have a table. We've created a table. Now, let us go ahead and say we want to get data from this table. Now, the way that SQL gets data from a table, SQL gets data from a table by using a select statement, okay? So we say select, okay? And then when you say select, you can specify what columns you want to select. If you don't specify the columns, you say select all, okay, from volunteers. Now, if you had 1 billion volunteers, this is going to be a terrible query to run because you're saying you want to select all volunteers. So usually you're going to have like a where clause or a way to limit the data that you're selecting. And that is why it is good for you to have things like a primary key, which are indexes that allow the database to optimize queries, okay? So moving on from that, we say select all from volunteers, and we're doing this because we know that our table is empty. Our table is empty, we just created it, so we're going to run this selection. So no result, 0 rows affected, okay? So there are no results that have been, no results. So there are absolutely no results, okay, for the table. What we can do, oh yes, oh yes, oh yes, what we can do is we can take a look at public. Now, public is a schema. In MySQL, schemas are different from schemas in Postgres, and in SQL Server, they're also different a little bit. So in Postgres, a schema is like a folder or a way that you can have different tables in different schemas, okay? So the default schema is the public schema, and that is where all the tables you create when you don't explicitly specify your schema or create a schema goes. So we come here and we say public, and we see volunteers. If we wanted to create a schema, just for learning purposes, we can say create schema rice, okay? And then we go ahead, we run this, and now we have a schema rice, okay? Now, if we wanted to create the if we wanted to create a table in Rice, we'd say create table rice.volunteers, and then here we can say name is a text and we say primary key, and we close the table and we go ahead and we run this and we have Rice. So here you see the schema, there's volunteers here, and in public there's volunteers as well. So the Rice schema, okay, can have a different table, different set of tables from your public, and if I wanted to select data from that, I would have to say select all from rice.volunteers. Okay, I have to say the schema name and the table name, and if I say run, it's going to run from that, and if I take away Rice from the front of this and I say just from volunteers, it's going to go to the public schema. Okay, it's going to go here because by default, when you don't put a schema, it goes to public. Is it clear? If you have any questions, please raise your hands. If not, we can continue. Okay? Now, one of the things that we can do is we can say insert into volunteers. Okay? And what are the things we want to insert into volunteers? We want to insert the government ID, okay? The name and the email, or we can say values, and we can say A102, okay? We can say the name, Vendire, and we can say here email z@ex.com, okay? Now, if we've inserted the first record into our table, okay? There are two ways to insert data. We can specify explicitly only the columns we want to insert data into by saying insert into volunteers, and then here we're going to say government ID and name, for instance, and then we say values and we provide just those values, okay? So you specify just the columns you want to insert data into, and you provide those values, and it will insert into those values and ignore the email, okay? So I'm not sure if we made email mandatory. I don't think we did. So let's come here and let's say B101, and here we say Toby McGuire, okay? Or let's say John Snow. So let's go ahead and run selection, and now we have two rows in our table. Okay, so let's go ahead and select all from volunteers, and let's see what that gives us. So now we see that the data that comes back appears like a table. If you take a look here, we have the government ID, okay, A1002, we have B1001, we have the name, and here, because remember when we were inserting John Snow, we said we don't want any data in the email, we want to insert just the government ID and the name, the email is null. Now, because the government ID is the primary key, it is impossible to have two records with the exact same government ID, okay? So if we come here, for instance, and we say insert into volunteers, and then we say values, okay, and we say B1001, and we say John Tigerian, for instance, and we say j@winterfell.com, okay, and we say run. It says duplicate key value violates unique constraint volunteers primary key. You cannot have two records with the same primary key, and it's important because imagine that you had two people called Jon Snow. Now, I have been in places where I had friends that had the same exact name, so you need a way to uniquely identify every single row that you have in your table. Again, to select data from a table, you say select all from volunteers, okay? And then let's go ahead and run this query, and then we have this data, okay? Now, again, if you had lots of data in your table, you don't want to do something like this. You don't want to say select all from, like, you don't want to do that, okay? So you're going to use probably where government ID is equals to this, or where something is equals to that, okay? And we can actually come here and say we want to alter table volunteers, and we want to add a column, and we want to call it age, and we want to make it an int, okay? Now, we have altered our table volunteers, we've added a new column, and then now if we say select all from volunteers, we're going to have an age column that is empty. Okay, so we have created a table, we have modified the data in the table, and then the reason why we were showing what a relational database looks like is so that when we talk about the tabular structure of a relational database, you understand exactly what we're talking about. Something else that we can do is we can actually install MongoDB and also use MongoDB and create a document in MongoDB, and then you'll see the differences between that. That might take a little more work, and it's outside the scope of our lesson, so let's just stick with what we're doing. So we have volunteers, okay? What is another table that we could create? I'm looking at you in the chat. So someone might have an idea for a table that we could create, and most likely create a relationship with. So it is possible for us to create tables, and then let's just, for the sake of it, let's say create table interventions, okay? And then here we're going to say we have a title, which is a text, and we want it to be primary key, okay? And then we have we're going to have the owner, okay? And this is going to be text, and it's going to be a foreign key that references volunteers and government ID, okay? And let's go ahead and create this table. So what did we do here exactly? For the sake of an example, we created a table called interventions, okay? And let's come here and say alter table interventions, rename to campaigns, okay? And we actually just changed the name of the table that we created to campaigns. So if you take a look at what we're writing as SQL, you'll notice that it's very English-like. So we're saying we want to alter the table interventions and rename it to campaigns. We want to alter the table interventions and add a column, and we give it the name of the column, and we give it a data type. So it's basically English. It's very, very English-like. It's not a difficult, the syntax is not difficult at all, and once you understand, you should be able to create tables and create relationships between tables fairly easily once you also understand how normalization works. Okay, so we have created the campaigns table, we created the volunteers table, and then we made sure that the volunteers are the owner for campaigns. Now, this is not how the application is going to work in the end, but for now, we want to make, there should be a correlation so that we can show how a foreign key works, okay? So if we want to insert data into campaigns, okay, we say insert into campaigns, okay, values, and then in campaigns we have build a bridge, okay, and then we have D4000, okay. This is going to fail because we're trying to create we're trying to insert into campaigns a value that doesn't exist in the table, in the reference table a value that doesn't exist in volunteers. So what exactly do we mean when we say something is a foreign key? Okay, when we say there's a relationship that exists between campaigns and volunteers. For this, maybe we should use a drawing, a diagram. So maybe we can take a look at, let's come here and say maybe draw.io. Okay. And let's save it to our Google Drive. Let's authorize. Okay, authorize. Authorize pop-ups. This is a blank diagram. That's great. Okay, so we have a blank diagram here. We're trying to explain the relationship that exists between two tables, okay? I see we have employees table, students table, products table. We can make examples with that as well. So here we have volunteers. And then here we have campaigns. So here the foreign key is, the primary key is the title, and here the foreign key is government ID, if I remember correctly. Okay, so what exactly is going on here? Now, the idea behind this is the owner, yes. So this foreign key, okay, now it is impossible for you to insert someone in the campaigns table that doesn't exist in the volunteers table, because we say that the owner has to be a volunteer. So if there is no volunteer, then you cannot add the owner, okay? It's impossible for you to have campaigns without having a volunteer, okay? And that's the whole idea behind having foreign key relationships. It's all about data integrity. You want to make sure, for instance, let's say you have a volunteer, and that volunteer is being deleted. You can specify what you want to happen to their campaigns. You can use the relationships that exist between the two tables to specify different things that can happen, so that at no point do you have data inconsistencies. Okay? So this is an example. That's why when we have the yes, insert into campaigns values, breathe a bridge, and we say D4000, it's not going to work. But if I can remember, I think it was B1001. That was correct? Yes. So we have someone with the ID B1001. Now, when we say select all from campaigns, and we say run, you see the owner is B1001. Now the owner of the Build a Bridge campaign is B1001, but we don't know who B1001 is unless we take a look at volunteers. So there's a way we can go about this. Okay, we can say select title owner from campaign C, and we say join volunteers B on we don't, we can just join volunteers V on C dot owner is equals to V dot government ID. Okay? So we can come here and let's say owner, and let's say the name. So what happened here was that we collected this name column from the government, from the volunteers table, okay? Because if we select only the select all from campaigns, campaigns doesn't have a name, okay? Campaigns doesn't have a name, and it's deliberate. It's deliberate because if you put a name in campaign, then if you wanted to change the name of the owner, you'd have to come to two tables to change the name. However, if the volunteer changes their name there, then you don't have to worry about data integrity because it's just going to be, correlate anyways. So there is no name here. So if you want to get like a full view of the data, then you'd have to start doing things like joining data across tables. And this is actually a very simple use case. There are times where you'd have to even join a table against itself. I have seen some really, really crazy queries in the wild using relational databases. There are times when you have to join like 6, 7, 8, 20 plus tables, for instance, just to make sense of the data. So there is a penalty to using relational databases in that regard, especially when it's very well normalized. But then again, it is a very powerful tool, and you can always denormalize. And yeah, so if we want to get the complete details, we're going to say title, owner name from campaigns, and then we're going to join volunteers on the campaigns, and that way we can get the name. We can also select other things from the volunteers table, like their the email address if we wanted to, and then join it here. Or we can also just select in the volunteers table and then join the campaigns to it, but then that's going to be a different query. Okay, now we covered quite a lot around creating tables, selecting from tables, altering tables, renaming tables, adding columns, adding values, inserting, and then we haven't talked about deleting, so maybe we should add, let's delete someone from volunteers, okay? So let's select all from volunteers, and let's delete someone after we select all from volunteers. So let's delete the Jon Snow that has the email null and the J@WF. Okay, let's delete this guy, okay? So we are going to come here and say delete from volunteers. Now you have to be super careful because if you don't specify the where clause, you can potentially drop and delete like your table. So you always want to make sure that you are specifying your where clause. So we say delete from volunteers where government ID is equals to C1001, and then if we run this and we say select all from volunteers and we run this, then the third row is gone. Okay, so we've taken a look at selecting, we've taken a look at inserting, we've taken a look at deleting. Okay, and let's do this then. Okay, so we've also updated volunteers, and now if we select all from volunteers, we should have the email there. Okay, so we've taken a look at delete, update, select, create, insert, and we have gone through much of the commands that you should, like much of the commands around working with data in a relational database. We also took a look at joins, and there are a couple of other queries like sum and average, aggregate queries, order by, limit. We're going to take a look at those when we start building the project and we start fetching data from the database, and we have built out an actual table that simulates what TBHI has in mind. Okay, so let's, are there any questions from this section? I know we breezed very, very quickly through it. I wanted to give a very, very quick introduction to databases. So if you don't have any exposure to it, then you have like exposure to the syntax. And then you can also see that it's actually quite simple. It's very, very, it reads like English, basically. Like delete from volunteers where government ID is equals to this, select all from volunteers, update volunteers, set email is equals to this, where government ID is equals to this. Like it's very, very English-like. Okay? I am going to copy all these commands and I'm going to paste them in the chat in case you want to copy them and put on your computer somewhere and take a look at them later. Okay. Now, over the next 3 minutes, your mission, should you choose to accept it, will be to create a very, very simple, so I see someone put a students table, create a very simple students table. Like not too much information, no first name, no last name, just the name of the student, the class of the student, and the student ID, just three columns, okay? Create a student table. Not all at once. Create a student table. With 3 columns, student ID, that is the primary key, the name, and the class. 2 more minutes. Who is creating the student table? 2 more minutes. Thanks, John. What will you do to this table to improve it a little bit? It's perfect, by the way it is. How would you improve it? So, John is the first student, the first participant to create a table in the session. Kudos to you, John. Thank you for sending the assignment in. Okay, so how do you improve this table? Now, something else we can also do, we can drop a table. It's something that I forgot to mention. You can drop a table. That is how you delete a table. Drop. The same thing for a database. You can drop a database. Okay? So, drop. Now, for this, we can say, we can make this int primary key generated always as identity start at 1000. Okay? And then the name, we're going to make this text, and we're going to call this classroom, and then we're going to come here, and then we're going to create a table, classrooms, and we're going to say the classroom, the name, it's a text primary key, and the description is a text, and then here we're just going to go ahead and then we're going to say the classroom is going to be a text, and it references classrooms name. And just like that, you have two tables where a student can only be in a classroom if the classroom exists. Okay? A student can only be in a classroom if the classroom exists. And so we've created the classroom. Okay, so now if we want to create a classroom, we can say insert into classrooms values. We're going to give the name of the classroom. Let's call it GWR, and okay, and we're going to run this and run selection. Now, if we want to insert into students, we can say insert into students, and then we're going to say the name, and we're going to say the classroom, and the values are going to be and then this is going to be GWR, okay? Now if we say select, and what you'll notice is we did not specify the ID. The reason we didn't specify the ID is because we said this is an integer, it's the primary key, and it is generated always. It is always going to be generated, and it's going to start at 1000. We can also even specify what we wanted to increment by, okay? So if we select then, select all from students, and then we go here and we say run selection. You have student ID 1000, name GWR. And if we say instead into students, okay, another John, this is also going to run because we didn't say the name is unique. So if we say again, we're going to have two Johns with different IDs. Is it clear? Any questions? None? Okay. I was hoping that I would get a couple of questions from this section, but it looks like everyone understood what we're laying down. Okay. Moving on. So, we have taken a look at how to create tables, select from tables, create relationships between two tables, a foreign key relationship. We've also taken a look at how to delete records from tables as well, and how to drop tables, how to create tables, how to create a schema, how to create a table in a schema. So we covered quite a lot in the very, very, very short time. I know we sped through quite a lot, but the idea was to get exposure to databases so that when we are working from Python and interacting with databases using the operation library, then it's not going to be magic what is going on as we use operation. Okay, so coming back then to what is here. Okay, so we have gone full cycle. We have touched on SQL, we've touched on Python, we've touched on JavaScript, we've touched CSS, we've touched HTML. So now we are about to go into implementing the pages, the designs, and as we implement, we're going to be explaining more complex concepts. So, let us move to the next stage, which is building the models. Now, earlier we talked about pip. We're talking about the PyPy, how pip installs from PyPy. And so we talked about install in heaven, and there are a couple of things that we also need to address when it comes to building web applications. Specifically, things like security, things like data validation to make sure that the data that is submitted is actually correct data and not malformed or malicious data. So to do all of this, a couple more libraries will be needed so we don't have to write everything from scratch. Now, there are a couple of things that we can use or things that we can leverage. We haven't touched on JSON extensively, but when building web applications, particularly web applications that leverage JavaScript, then JSON is often the lingua franca or the EDI format of choice. So, keeping this in mind, let us start implementing a couple of the models that will be required for the application to be able to get sample data and register enablers as well as volunteers. So the first thing we're going to create here, we're going to create a volunteers.py file, and then we're going to create an enablers.py file. Now, before we continue, it is pertinent that we explain what exactly the different packages in the repository, what they mean. So, we have the virtual environment here. Who can remember what the virtual environment is? Now we're explaining what happens and how you structure how you structure a web application. The virtual environment was what we created when we were trying to separate our Python installation from the main installation of the computer. Okay? And who can remember the command we used to create the Python virtual environment? Who can remember the command we used to create the Python virtual environment? Not all at once. Okay? Is it that we don't remember? Well, I'm hoping someone can type it in the chat later. Moving on. So, in software development parlance, middlewares are things that run when your application is starting up, okay? They sit between your application and the main logic between the startup point and the main logic of when your application runs, okay? Models try to encapsulate and model your data to as much as possible from the presentation or from the collation from the API and to persistence to your database. So they kind of act like a relational object mapper for your data. Now, the public folder is a folder where the docs, the images, the CSS files, and whatnot sit. Now, this file was created for learning purposes, so was the source file. And
Can you be eating and teaching? You need to eat.
an exercise. Once I give an exercise.
Except you got access.
Once I give an exercise.
Okay, okay.
Okay, so the templates folder is where we keep all the templates. The templates folder is where we keep all the templates. The test is where we write the tests to test our application. Git ignore, who can remember what git ignore does? Anyone? What does git ignore do? What does git ignore do?
You need to eat. It's oats, at least. It's soft food. You don't need to. I think you can be walking now.
Anyone?
So they should eat it up, Abi.
Yes, thank you. What does git ignore do? If you know it, you can just raise your hands. Is there anyone that was around during the Git tutorial? Is there anyone that was around during the Git tutorial? No one knows what git ignore does? Eileen? What does git ignore do? Donald? Celestine? No one knows what git ignore does. Well, exactly. So in the Git section, we talked about git ignore and how git ignore helps you keep your workspace clean. Now, we also talked about what happens when you initialize Git in a repository, what tracking does, the diffing algorithm, and a couple of other things as well. So yes, 100% spot on. Okay. Moving on, index.js, we're going to remove this. Main.py is where we have our application, and then pages.py is where the renderers sit. So what we are going to do before we start, I'm going to give a short 4-minute exercise to touch base on what has been taught so far. How do you add a column to a table?
3 minutes ago?
So the biggest for you, you'll be eating now as you're walking. So
Not-
after you eat, you want to rest.
Oh my.
You don't want to.
No, it's a.
Time. You have to be eating them while you're walking.
Mhm.
A little bit more coffee.
Yes, please. How do you add a column to a table? I can give you a hint. You have to alter the table. You can Google. Remember, I said one of the superpowers you should have is to find information. Okay. Let's see moment of truth for Donald. Okay. And the award goes to Donald. Thank you, thank you, thank you. Okay, moving on. So what we're going to do now is we're going to work on implementing. So we are going to take a look at the templates, what we talked about. Connecting the front end to the rendering primitives that the application has. So let's go ahead and remove the style data. One of the things that we're going to do now is we're going to have to update Balmer from 0.94 to 1.02.
Okay, so we have moved and we have updated the style sheet for the website, and now we're going to take a look at how to tie everything together. Earlier we were taking a look at the application and how Heaven makes it easier for you to build web apps. We took a look at the main app. We took a look at the main app, and we talked about how the assets and the public folder, how they work together to both render assets and to render HTML files. We also took a look at the internals of Heaven. We experimented a bit with dynamic domains, and now we're going to start implementing APIs. So if you remember, one of the things that we wanted to do to implement APIs is we wanted to create the ability for the web application to be able to respond. So what we're going to do now is we're going to go ahead and create the different routes. So now remember, the app is an instance of the application. The web server receives the requests from the browser. So you have the Nginx Accelerated Reverse Proxy connecting to the Heaven web server. So Nginx receives the request and then pipes it into Heaven, and then Heaven takes that request, and then it goes through an internal routing mechanism to specify which specific function is going to handle the request. Now, there are a couple of ways that we can go specifically around the requests, how they are handled, and whatnot. One of the things that we're going to try and demonstrate now is something called higher order functions. So we have already taken a look at the syntax for functions. We've taken a look at the syntax for classes. We've taken a look at methods. We talked about the self. Now let's talk about higher order functions. Now, if we go ahead and say we wanted to create the portal, one of the things that we'll have to do is to specify if we wanted the portal to exist on a subdomain or if we want the portal to exist on the regular website. So for the portal to exist in a subdomain, we have to do app.subdomain, and we're going to put portal. And then here, we'll go ahead and say portal. Okay? So this creates a subdomain. Now, who can guess what the app.subdomain is? Is it a method? Is it a variable? Is it a method? Is it a variable? It's a method. How do we know it's a method? Okay? A method is the only thing that you can call, particularly when you're using dot notation on something else. If it were a variable, it will just be app the subdomain, and then it wouldn't be something that has the parentheses and accepts anything. Okay? So app the subdomain portal, we are creating a new subdomain. But what exactly is the subdomain? What do we mean when we say something is a subdomain? If you go to a couple of websites, for instance, if we say you went to or we go to careers that, let's say, Google.com. Now, what you notice is that we went to when you go to a website and the website starts with something like careers.google.com, okay, or you have like partners.microsoft.com, or partners that or something like an aws.amazon.com. That's the perfect example. Now, Amazon is notorious for being an e-commerce platform. Okay, so if we went to www.amazon.com, what you're going to see is the e-commerce platform. Okay, you can buy items, you can shop, and whatnot. We're not marketing Amazon, we're just using them as an example for a subdomain. Now, if you come to aws.amazon.com, however, it's a completely different ballgame. It's a very serious data center cloud platform for building applications, hosting enterprise apps, infrastructure, and whatnot, tooling. So this shows you the power of subdomains, okay? If you visit Amazon.com, it's the e-commerce platform, you buy stuff, but just by changing the subdomain and moving from www, coming to AWS, that takes you to a completely different context. So subdomains are a very, very powerful tool. Many government organizations, enterprise organizations, they leverage subdomains and they use it as powerful tools and agents to carry out their mandates and their missions. So the subdomain is when you visit a website, you have the www, okay, and then you can have a subdomain that is a completely different, and you can actually route your subdomain to even a different IP address. It doesn't have to sit in the same IP address as your main website. Okay, so to enable a subdomain in Heaven, what you're going to have to do is to call the app.subdomain method and pass in the passing subdomain that you want to enable. Now, that is just the first step. After you have enabled the subdomain, the next step would be to make sure that the subdomain is able to render the assets and the CSS files, because the way the content, the way that your browser is set up is that if you have logged in on one subdomain, and rightfully so, because imagine that you went to a company where, let's say, you had tvhi.workstation.ng, and then because you signed into tvhi.workstation.ng, you went to vduplex workstation.ng, and you were also signed in. So the subdomains are always very they're separate. The security is separate. Everything about them is separate. Okay. So when you activate a subdomain, you also want to make sure that the JavaScript files and the CSS and all of that can also work on that subdomain. So let's come here and do that. To do that, we say app.assets, and then we say public
and the subdomain it's going to be the portal. And just with that, we're good and we're ready to serve on that subdomain. But then, in all honesty, there's nothing that's going to happen at that subdomain because we haven't done any route handling. Okay? If you take a look at the main page, the files that the things that we have there are mostly around the index and the dynamic that we took a look at earlier. So to be able to handle route at the subdomain, we need to be able to call app.get, app.post on the subdomain. So to call app.get, app.post on the subdomain, we are going to have to say app.get, and then we're going to give it the slash. And then if we put the method we want to call, we would now specify the subdomain as the final argument, and then we'll pass the name of the subdomain that we wanted. Okay, so here we have created the first route handler, but the route handler that we created for the subdomain is the same as the route handler that runs on the index page. However, it's for example purposes. I would like us all to take a look at the route handler as it currently is on the subdomain, and then what do you notice is the difference between the route handler for the subdomain versus the route handler where we have app.get pages.index versus the one where we have app.get and the subdomain is involved. Remember we talked about how you have default arguments, okay? There are default arguments. So the fact that we have the ability to add the subdomain on line 35 to app.get means that the app.get on line 31 and the app.get on line 32 are using default subdomain values. They're using default subdomain values. So one of the things that will help you grow as an engineer is when you spend a lot more time, like curiosity time, exploring what is actually going on behind the scenes. So let's click here and take a look, and we see subdomain here is default. So this is default subdomain, and that default is www. So automatically, just by browsing the code, we can see that this two are at the www or the default subdomain, and this is at the portal subdomain. So in order to be able to have a different HTML page rendered, what are we going to do? What are we going to do in order to be able to have a different HTML page rendered? What are we going to do on the file? Based on the information that we had shared earlier, what do we need to change in line 35 if we want to have a different page from the page that is rendered on line 31? what do we have to do on line 35 to change the page? Because if you take a look at line 31 and line 35, there's something similar, page.index. So what do we have to do to change what you'll get if you visited the portal subdomain from what you'll get if you visited the home page? Well, one of the things we talked about when we were taking a look at the app.get, we said the first part of app.get tells you the address on the server, and the second part of app.get gives you the name of the function that is going to be called. So when we take a look at line 35, the first part tells you the address, the second part gives you the name of the function that's going to be called. The third part says that it's only going to be called if the subdomain is equals to portal. So that means that if we open our browser and we go to the portal dot localhost we're going to get the same exact page as we get if we went to the home page. And we want to change that. So what do we have to do to change it? Well, we're going to have to async def, we're going to have to create a new function that will be called instead of the index function. So what are we going to call this index function? What are we going to call this new function that's going to be called? Well, a good name will be portal. And what are the arguments that we have to pass into this function? And this should be easy. Unless we're super exhausted, this should be particularly easy. What are the arguments that we are going to pass into the function that we have on the screen? Why can't you record? Okay, so I was not recording the meeting, I just started recording. Apologies for that. Okay, so what exactly let's go here and let's take a look at the okay, so what are the things we have to put inside this portal? What are the things we have to put inside this portal? What are the things we have to put inside portal? Who can remember? Is everyone tired? Are we exhausted? Taking a look at the functions above, what are the things that we have to put into the portal function for it to be able to handle HTTP requests. Okay, so now that we have completed the portal, what needs to be done on this line 18 for us to return a HTML page? Do we have any questions? Everyone follow me? Is it that we don't understand, or we're tired, or what exactly is? What do we need to do on line 18 to return? What do we need to do on line 18 to return a HTML page back to the browser? Okay, so what we're going to do is I'm going to leave the line 17, and I'm going to put a pass here, and when someone has done the research for what needs to be on line 18 for the application to send a response back to the browser, I'm going to come there and fill it out, okay? Now, having asked that question, is there any topic that has been covered in the past couple of hours that we want to touch before we move on? We have a couple of people in the class, and there's not a lot of engagement and not a lot of interactivity. Okay, no questions. Okay, so if there are no questions, what then are we supposed to do on line 18 to return a response to the browser? On line 18, we're supposed to return something to the browser. On line 18, we're supposed to return something. The browser. When you take a look at the functions above, what are we supposed to do on line 18? Yes, we're supposed to do something with the response, but what exactly is that? Are we returning the response? Are we awaiting the response? So, whilst we are, like, if you take a look at the functions above, there are a couple of things, like, if you take a look at line 6, something is happening on line 6. What is happening on line 6? We're awaiting the response. Perfect. We are awaiting the response, but we're not just awaiting the response, we are rendering. We are awaiting the render. We are awaiting the render. We are awaiting the response to render. We want the response object to render the HTML file. We are awaiting the response, exactly. So on line 18, what we are going to do is we're going to await the response to render. And that's what I was hoping that we will all grok. Await response dot render. And for here, we have to make it the portal.html because it's different. Now, if we visit this page now, we most likely will get an error, and I want one of us to read Okay, so we have the error, and when we take a look at this page, it might look like it's intimidating, but this is what I want to use to give an overview of the stack trace, okay? Now, whenever you execute in code and you encounter an error, the programming language tries its possible best to give you context on what happened and where it went wrong. What happened and where it went wrong. So in this case, if we take a look at what is on the screen, the traceback, okay, starting from the top all the way down to the bottom, just before we have the info internal server error, you'll notice that there is something called template not found portal.html. Template not found portal.html. What that means is that we have put a template called portal.html, but that template does not exist. So we need to create the template called portal.html. Now, why am I saying this? So you understand what happens in the handler functions that you pass to the Heaven application. So you understand what happens in the handler functions that you pass to the Heaven application. When you have a handler function and you say response.render, the file you're trying to render must absolutely exist. The file you're trying to render must absolutely exist. Okay? So in this case, the application has returned a 500 internal server error because the template was not found. So what do we need to do to fix this error, knowing that the template was not found? No, so what we have to do here is to create the portal.html file in the templates. So come here, we create portal.html, and then when we do that, so you notice that when the portal.html file is created, most of the errors disappear. Most of the errors disappear. So we're going to create portal.html file, and then what we need to do in the portal.html file, we need to style and design what we want the portal to look like. We need to style and design what we want the portal to look like. Now, having said that, let us take a look at what exactly it entails to have the portal, to some degree, resemble the rest of the site. We're first going to start with the extents. Okay? We're going to start with the extents, and then we're going to come down here, and we're going to say block isol, and then we're going to end block. And then here we say layout.ginger, and then, okay, so we have something that looks consistent with the rest of the application, but we might need to change a little bit of styles so that it is clear that this is the portal. So what we need to do inside here, remember we talked about HTML, and then we said that HTML, we have, whenever you're opening your HTML tag, there are two things that are super important: the class and ID. So here we're using a class called section. It's too sweet sugar. It's going to shut me down. So HTML, we need to have an opening tag, a closing tag, there's the ID, and there's the section, the class. So here, we're trying to put the section, and then we're going to put information. Let's put a paragraph, and we say information about the portal. Okay? Information about the portal. So here we have layout.ginger, but the layout.ginger file, if we take a look at it, might not be exactly what we need for the portal, so we might need to duplicate this file and create a separate Okay, so what we have done now is we have duplicated no sugar.
You don't want sugar at all.
So what we have done now is we have created the portal.ginger so we can use it separate away from the existing layout of Ginger. Now, remember, we talked about how an application can create your web pages so you don't have to create web pages manually. An application can create web pages so you don't have to create the web pages manually. So here we have the portal.ginger, and there are a couple of things that are carried over from the layout that we have to get rid of. Now, part of it is the sections that exist, and a couple of other inconsistent design styles. Earlier when we started the session, we were talking about HTML, we were talking about CSS. We mentioned how everything that should be concerned with styling and links should be in your head. And then you can have the scripts in the body if you want the data to be rendered, the page to be rendered before there is any processing logic done. Now, we also took a look at the Alpine.js, and we started working on the HTML file. And after we worked on the HTML file, we moved over to Python so that we could tie everything together. Now we're going to go back to the HTML file so we can complete much of the work that we were doing with Alpine.js. Okay? To be able to do that, we need to redefine how this page looks. We need to redefine how this page looks. So I'm going to be redefining how the page looks and using it as a teaching material so that we are able to understand and work and replicate it. Now, the idea is at the end of this exercise, we are able to answer questions on why what was done, and then share a couple of code snippets in the chat as well. Okay? So, moving into it. First things first, we have a couple of sections here that we need to get rid of. Okay, so we have the footer, and now we can work on the portal without any impediment. So let's take a look at what exactly needs to be done. Let's take a look at the header tag. Earlier we talked about how we have styles in the header, and we talked about the design system. We built a styles.css file, but then we checked it into a GWR repository, and then we checked out the enablers, but we did not check out the styles.css file. And then I mentioned how we can check out just a file from another branch, and I showed the code to do it. Can anyone remember what that code was? If we can, it will be good if you share it. If you can't, I'm just going to go ahead and type it so that we can check out the file and continue the learning process together. Okay, so we have checked out the file from GWR branch, and now we have some semblance of a design system here in public. Now, one of the things that we said was necessary is put, so earlier we talked about how we had a div, the card, and how we could style the card. So we also talked about the different header tags that exist. So if we want to go ahead and follow the design style that we mentioned, let's take a quick look and let's recap what we talked about. Let's take a look at styles of CSS. What did we talk about? We talked about how you want to have nothing more than 5 colors. We took a look at some of the 5 colors we wanted to have. We had a negative color, positive color, tertiary, secondary, primary. We talked about the button primary, secondary. We took a look at the card and a couple of input elements, the tables, the typo, and now it's going to the application of those design styles to the portal. One of the things that is missing is a nav. So if we opened up Bulma, we should be able to see a couple of the classes that we need. Again, remember, the idea is you should be able to find information very, very quickly. So coming to Bulma, you should see that the class that is needed is an alpha. You should see the different styles used. And we are going to go ahead and just create a navbar out of scratch. As a placeholder, and the idea is that later down the line, I hope some of the students, after taking a look at Balmer, can give hints as to how to style this. So I'm just putting a placeholder there. So your mission, should you choose to accept it, will be to take a look at the Balmer styles and then suggest things that can be done for this navbar later. Okay? So we have been able to separate the look and feel of the portal, create a subdomain, and then separate the rendering of the subdomain with your help by identifying what exactly needs to be done and creating a new HTML file that captures the design changes that need to be done on the portal subdomain. Now, if there are any questions, you can ask. If there are any questions, I'm going to continue. We're going to talk about introductions to APIs and REST. And one of the things that I was trying to achieve with this was to set the ball rolling so we can use the user interface. But we can also just use .http, and we were talking about hypermedia as the engine of application state earlier, okay? And we were explaining that when you visit a website, there is a path that the application is concerned with, which is the route. And we talk about the dynamic routes. So having spoken about dynamic routes, let us now take a look at what it takes to build RESTful APIs. Because we're trying to build a web application. What does it take to build RESTful APIs? Now, there are different school of thoughts that exist in this. One of the things that is prevalent across all is that you want to make sure that your APIs are self-descriptive and you use the right HTTP status codes, you use the right methods. We earlier talked about how you use get for creating, you use post for creating, you use delete for removing. And so far we have taken a look at get, but we have not taken a look at delete, and we haven't taken a look at the put and patch. So let's go ahead and create the delete. And let's give it the execution and go ahead and say volunteers. Okay, so we're going to go ahead and add some placeholders that should be able to stand in place for this route endpoint. Now, how do we create a placeholder? Remember, we talked about that when you're creating an application that is supposed to be a handler, it should accept 3 arguments. So we're just reinforcing and going ahead to do that. So we say async def. Placeholder, it takes a request, takes a response, and then the last one, if you set context, you correct. And then inside here, we're just going to pass, and we're going to put it here. Which is a placeholder. Page is a placeholder. Okay, and if you want to delete something, usually you want to make sure that the delete doesn't go to a noun endpoint as much as it goes to a specific endpoint. So usually if you want to create, let's say you wanted to, you had a, we're looking at Amazon, you had your own e-commerce platform or your shopping platform, and you wanted to give people the ability to create new products. What you were going to do then would be you probably would have them post to products, but then when they wanted to delete a product, they wanted